Ever wondered what happens inside your computer when you add two numbers? Today we're following one command through the von Neumann architecture, the foundation of every computer you've ever used. Let's dive in. Our task is simple. Add two numbers. A plus B equals C. 10 plus 20. That's it. But this one instruction will take us through an incredible journey inside your CPU. First, the big idea, the stored program concept. In von Neumann architecture, both your data and your instructions live together in main memory. Before this, computers had to be physically rewired for different tasks. This 1945 design was revolutionary and still powers every device today. Look at main memory. It's like a massive library. Our instruction ADD sits right next to the data, 10 and 20. Space is reserved for C, our answer. Everything the computer needs is here, organized and waiting. The CPU has to fetch each piece when it needs it. Now the action begins. The fetch cycle. The CPU requests the first instruction. Watch the ADD command travel from main memory through the system bus to the CPU. This is where the real work happens. Meet the control unit, the director of this operation. It reads the instruction and coordinates everything. It generates timing signals to keep things in sequence, then sends control signals to every component, telling them what to do and when. Here's the problem: the speed mismatch. The CPU processes billions of operations per second. Main memory is fast, but significantly slower. If the CPU waited for memory every time, the system would crawl. This bottleneck needed a solution. The solution: registers. The CPU's personal Scratchpad. Extremely fast, extremely small memory units built directly into the processor. They're a high-speed staging area for data the CPU needs right now. No waiting. Problem solved. Watch the data move. The values 10 and 20 are fetched from main memory and loaded into registers inside the CPU. Now they're ready, sitting nanoseconds away from where the calculation happens. This is where the magic happens. The ALU arithmetic logic unit. It contains all the circuits for operations: addition, subtraction, multiplication, and logic gates. The ALU grabs 10 and 20 from the registers and executes the ADD command instantly. The result? 30. It's stored in a special register called the accumulator. This holds the output temporarily in the high-speed CPU environment. Everything's still moving at CPU speed. Journey home. The control unit issues the final command. Store the result. 30 travels back through the system bus to main memory. The instruction, C equals A plus B, is complete. Here's the mind-blowing part. We followed one journey. But modern processors do this entire cycle billions of times every second. Billions. Your phone right now is executing this constantly, at an unimaginable scale. This is the enduring blueprint. Other designs exist, like Harvard architecture, but von Neumann's flexibility made it dominant. The device you're on right now? It's a direct descendant of this 1945 design. From a single command, an entire digital world is built. A choreographed dance between memory, control, and logic, repeated billions of times. That's how computers work. If this fascinated you, hit subscribe. Which part surprised you most? Comment below. Thanks for watching.